So spanning tree is a very good protocol in preventing loop. This is the best in layer 2 domain. You may have any other option, but they are not that good and automatic like spanning tree. To prevent loop, you may have other options like manually shutting down a port whenever there is a redundant path. But those are all not dynamic. Dynamically shutting down the port and unshutting the port whenever it's necessary is done by spanning tree. It is good. But the bad side of spanning tree is also there. What is that? By shutting down a port, by blocking a port, I should not say shut down. The port is not going really shut down. The port is still operational for the management traffics. Only our traffics they don't allow to pass. By blocking the port, spanning tree prevents loop. At the same time, it is not allowing us to utilize our resources optimally. By putting one link as standby, you lose the resource connected via that link. You lose the bandwidth, you lose the switches. That's one part. We are not going to focus on that side. The other side of spanning trees cons is the security. Everyone knows that spanning tree uses priority and the MAC address. What if someone brings a switch with low priority and low MAC address? They can become a root switch. That someone can become a root switch, which is dangerous. We don't have authentication in spanning tree. We don't have authentication. So spanning tree is going to accept the BPDUs, and if it finds a BPDU superior from a switch, automatically the role change happens and that the switch with the superior BPDU becomes the root switch, which is dangerous. Spanning tree roles or not, they are preemptive. Spanning tree roles are preemptive, meaning if there is a superior BPDU comes, the current root switch will give up and make the new switch as a root switch, which means there is a preemption. Attackers can use this as the tool to confuse our network, to spoil our network. Yes. You see here, there's a computer at the down, and there are two computers at the bottom. The ports that are connected to those computers, if they are not port fast configured, what happens is there will be superior BPDU coming from the attacker, this computer, if this is an attacker computer, if there's superior BPDU coming in, then the PC will be considered as a root switch, which will confuse our network. I think these things we have seen in the previous class. To avoid that, what we do, we configure switch port mode access. Someone can negotiate trunk, let me take you back and show you what I'm trying to say. We saw here an attacker negotiating trunk to avoid that reconfigured access. Not only that, an attacker can also become a root switch by sending superior BPD. To avoid such thing, we can protect our network by enabling port fast. See, protecting the operations of STP, protecting against switch being added on the port. BPDU guard shuts the port down. BPDU filter specifies the action to be taken when BPDUs are received. Okay, these three are three different things. Number one, whenever we have STP, it is recommended to enable port fast on all the host ports, host connected ports. Enable port fast. Port fast enabled ports will not wait for BPDU responses. When we learned RSTP, we learned this. Enabling port fast disables the spanning tree is one of the statements what most of the people will use, which is not really true. We are not disabling spanning tree. We are telling the port not to wait for BPDU responses. Don't expect any BPDUs to come in from there. That's the meaning of port fast. So that's one way, you don't expect BPDU, which means that you are not expecting any switch to be there on that port. Secondly, you can enable BPDU guard. See, if this computer, if it pretends like a switch, what does that mean? If it can send BPDU like a switch, then only confusion will happen. What if I put BPDU guard? I said no, BPDU is allowed. That is what called as BPDU guard. I don't want to expect any BPDUs in this. I don't expect any BPDUs in this port. That is what BPDU guard means. I don't expect any BPDU in this port. That is what we call as BPDU guard. I don't expect any BPDU on this port. No BPDU. If BPDU comes in for security, it's going to shut down the port. Because I'm very sure that if there will be a BPDU coming in, it is not from my genuine legitimate device. There's something bad going on there. There's someone bad sitting there. So to protect our STP's behavior getting poisoned, we enable BPDU guard on all the access port. It is good. A recommended configuration. Enable port fast. Put those port in an unused VLAN if you are not going to use any port. If it is an using port, it is okay, but at least enable port first. Let it be a member of some VLAN, that doesn't matter. Enable port first. Enable BPDU guard. So that if any BPDU comes on that port will go to inconsistency state. In another word, shut down. That port is going to be shut down. The next one is the BPD filter. BPD filter is also same like BPD guard. When we put BPDU filter, no BPDUs are expected. If BPDU comes, BPDU filter just ignores those BPDU. That's the action. It ignores the BPDU, keeps the port up. BPDU God shuts the port immediately. If BPDU comes, BPDU God will shut the port. Whereas BPDU filter, you have an action option. You have an option to say this is the action to be taken. The default action when you enable BPD filter is just ignore those BPDUs, filter those BPDUs coming in. Filter it, don't allow them inside. Keep the port up. So in short, if I need to say the difference between BPD God and BPD filter, BPD filter, when BPD comes, it will just filter out. It won't accept BPDUs inside. Keeps the port active for the traffic. Only the BPDUs are not allowed inside. Whereas BPDU God shuts down the port completely. The port will not be in use unless you go and bring it up again. Alright, this is the command to enable BPDU God. In the global configuration mode, we go and say spanning tree port first BPDU God. This enables the BPDU God on all ports. But we may not be willing to enable BPDU God on all ports. You should not enable BPDU God on all ports. Why? The link that is connected between the switches needs BPDU, isn't it? They need BPDU. So you need to go and enable on the interface instead of global. Here they are not showing the command. I'll show you when we do the lab. Here this command enables BPDU globally. BPDU filter. This is the command to enable BPDU filter. Spanning tree port first. BPD filter. All these things can also be enabled per interface. Here they are showing only the global configuration mode and verification. Alright, so we have seen so far BPD God and BPD filter. If BPD comes in, it will go into inconsistency state. Let me check whether the packet tracer supports this so that we can do some. Right, let's enable this and test it here. I'll go to interface Ethernet 0/0 spanning tree port first. H spanning tree port for spanning tree BPDU. Okay, BPDU God enable. So this is interface level command, which was not there in the presentation. We got a switch, and we got the switch with the root God enabled. Root God is enabled on this port, which means, BPDU God is enabled on this port, which means if any BPDU comes on this port, the port should go shut down, right? Currently, if you see here, show IP interface brief, I can see the interfaces are up. The interfaces are up. And now I'm expecting, as soon as I on this router, a BPD will be sent and this port will go down. because of the BPDU guard. Show spanning tree BPDU port fast. Show spanning tree summary total. We can see that BPDU guard. What is this? Disabled. I think I have enabled globally also. BPDU spanning tree port first. BPDU. We don't have that command here. Spanning tree BPDU. Spanning tree for VLAN 1. Spanning tree port first. Spanning tree. I have enabled that. Spanning tree interface. I already enabled this. Do show run interface Ethernet 0/0. See, we have these two commands already there. So verification command is show spanning tree summary total. Show spanning tree. Let me see totals. It shows the global spanning tree port fast edge BPD. Okay, it is under this one. Edge BPDU God. So only those edge ports. We have this. Okay, only the slight variation in the command. Here we don't have that keyword edge in the presentation. Port fast edge BPDU God default. Okay. All edge ports now enabled with BPDU God. Let's go and verify now. Show spanning tree summary total. Yes, it is enabled. It is enabled. Now, is there any other command that I can see? Show interface Ethernet 0/0. Okay, what do we see here? It's in forwarding state, so only this mesh. Okay, fine, no problem. We have enabled BPD code on this interface, and it's an edge port. Currently, we can see it is enabled, and the interface is up. Show IP interface. Interface is up. I just want to enable the switch so that it will send some BPDU and see what happens. As that switch boots, I'm expecting some changes here. As soon as that switch boots up, the BPD will come, and I'm expecting the port to go down. Okay, we got it. Nice. You see, as soon as the BPD is received on E00, because BPD got is enabled, the port got disabled. The port has gone to error disabled state. BPD got error detected, putting this Ethernet 00 into error disabled state. Done. Let's verify. Show IP interface brief. Down. Show spanning tree summary. Out of 4 ports, now it is only 3 ports because one has gone to down. Show spanning tree error disable. Show error disable. For BPD got error disable is enabled. That's why it got anyway. It got shut down. Show error disable. Shows spanning tree. Why? I want to see, okay, inconsistent port. This is what I want to see. I want to see all those ports that gone to inconsistent state. But I saw the log saying, okay, it's error disabled, not inconsistent. Error disabled. Show spanning tree error. We don't have such command. Okay, so how will you bring this interface up? To bring the interface up, we need to go under E00. If you simply say no shutdown, it is not enough. It won't come up. You see, still it's not coming up. You must shut down it manually. All right, and then we need to bring it up. But as soon as it comes up, again it will receive BPDU, again it will go to error disable state, you see. BPDU is received, so it is going down. To bring the interface up, you have to shut down manually. That's what I want to say. Next. What if I don't want this to be manually done? I want the port to come up automatically without me interfering into, without me getting into the interface and saying shut down and no shutdown. I want it to come up automatically. And again, if BPDU is received, it will go down again. But anyway, I want it to come often as a normal port. What if the BPDU, the attacker, stops attacking? What if that switch 2 is removed and proper, genuine PC is connected? How do we know? For that, I need to go inside the switch every time, shut down, no shutdown, which is going to take a lot of time. To automate it, we can enable something called error disable recovery. It will recover the port automatically. You can say every 1 minute you come and check, bring it up, check if BPD is not received. Good. If BPD is received, again you shut down. Again you check after 1 minute. So you can automate it instead of we shutting down and bringing it up. We can make the switch itself to unshut. By default, after every 5 minutes, it will do if you enable, again, only if you enable error disabled recovery, which we have not enabled now. Because you have not enabled now, we have to manually get inside and shut down and no shutdown to bring it up. I just showed you. I have to shut down once and then bring it up. But if you want this to be automatically done, you need to enable something called error disable recovery. That will do only every 5 minutes. It will bring the interface up after 5 minutes, and if the problem continues again, it will go to shutdown state. See, the interface has come up. I think the other switch 2 is not sending any BPDU now. No idea why. It's supposed to send BPDU every 2 seconds for some reason. The other switch is not sending BPDU. Is it true? How is it possible? Switch 2, are you alive? Again BPD is received, again it has gone down. I want this to be automated. How? Spanning tree, error disable, spanning tree or error disable, no spanning tree, just error disable recovery cause because of BPDU God enabled. I enabled the automation. So if the port goes down, it will come up after 5 minutes. You can see that by typing show error disable recovery. You see that for BPDU God, I have just enabled. You see, enabled. For all the rest, it is disabled. And if you go down here, every 5 minutes, it will bring it up. 300 seconds is 5 minutes, isn't it? So the time left is 284 seconds, after which the port will come up. But it's too long, no? We cannot wait for this to work. So let us go and change the timer. Error disable recovery cause BPD God. Interval. I would like to bring it up every 30 seconds. Okay, just 30 seconds, not 300 seconds. Now let's verify this. You see, 300 seconds now. Time interval is 300 seconds. Wait, one time I need to, this is older timer for BPD God. I'll shut down that port. And bring it up. Now again it is blocked because of BPDU. The interface has gone down. You see only 22 seconds left. You see now? It's only 22 seconds left. After 22 seconds, it will check. After 16 seconds, it will bring it up. Wait for 16 seconds. It will bring it up. And again, if BPDU comes, again it will put it into error disable state. See? It got recovered because of error disabled recovery, but again BPD is received, so it is again gone to error disabled state. I'll do one thing, I'll go to this port, switch and shut down this port so that it won't send any BPDU. Yeah? On switch 2, I have shut down the port. As a result, on switch 1, you see the port will come up and it will stay up stable. Right now it is in down state. See, recovery, the protocol has come up, line protocol has come up. It won't go down. Show IP interface brief, I should see the interface is up. And again, if I go to the other switch and say unshut, BPD will come and put this down. See again. Show IP interface brief. I can see the interfaces are down. I go there and shut down and wait for this to come up and it will stay up. Attempts to recover BPDU. Okay, now interface is up, it will stay up. Right, this is BPDU God. BPDU God will shut down. Let us enable BPDU filter now. Two things we have seen, BPDU God and BPDU God error disable recovery. Two things, right? Error disable recovery. Now, wait, I want to show you one more show command. So I'll say no shut and it is going to go down now. Okay, now show spanning tree error disable, no, show error disable not this one. Show BPDU, show inconsistency state, show spanning tree inconsistent. It's not showing here. I'm expecting the port which is right now in inconsistency state to be shown here. Because this particular port is right now in inconsistency state, it's gone down. That command is not working, I'm sorry. Now let's move on to the other topic, BPD filter. I'm going to enable BPD filter on the other side. Let's do the globally, because we have configured edge port already. I can say show spanning tree BP spanning tree port fast enable ports edge port BPDU filter default, right? BPD filter default, BPD God I want to remove, which we configured long back. I enable only BPD filter. Now let me say no shutdown here. I said no shutdown. Definitely BPDU is going to be received. You see, received BPDU detected, putting into error disable state, line protocol is down. Show IP interface brief, it is done. But in BPD filter, you have an option to say just ignore only the BPDU that comes in. Let's check for the option. BPDU filter default. Let's go under the interface and check. Interface Ethernet 0/0 spanning tree port fast edge. No. Spanning tree BPDU filter enable. There's only enable option. We're waiting for the 30th second. Okay, now you see, I should enable on the port. The port stays up even though the BPD is received. Even though the BPD is received, the port stays up. You see, show run interface Ethernet 0/0. The reason why it was not working earlier is I had this command. I should have removed this. That is why I was not seeing the result that I want to see. When you have a BPDU filter, the port will not go down. Only the BPDUs that are entering will be filtered. Of course, they are sending BPDU now. The other switch is sending BPDU. I can shut down once and say for shut down. Definitely BPDs are sent, but BPDs are not allowed inside. Without shutting down the port, the BPDs are filtered, so attack is avoided. The port still remains up because we have enabled BPD filter. Show spanning tree, summary, total. You can see the filter is enabled now. As a result, there is no shutting of port. That's what we saw there in the presentation. It says BPD filter specifies the action to be taken when the BPD is received. The action is, just filter, that's all. BPD God will shut down the port. BPD filter will just filter. So along with this, we also saw another feature called error disable recovery. Don't forget that command. If you want, I can show you once the command. The command is in the global configuration mode. Sorry, let me show the command on switch 2 because error disable recovery caused because of what? What reason the error disable happens? In our case, it is BPDU God. You can have the same feature for many things like ARP inspection. If because of ARP inspection, if it goes down, because of some strom control, meaning you have set control like how many packets per second the port can receive. Some strom is coming. If too many packets is coming, that's what called a strom. If strom is coming, the port will go shut down. Then after how many seconds it needs to get recovered. Likewise, we learned about port security. Port security also shuts down the port, right? Yes or no? Port security, we have three violations. What are they? Shut down and protect, isn't it? Now, if it is shut down, you can use this option to bring it up automatically. Got it? And you can say the timer, recover interval. You can say after how many seconds it needs to bring it up if it is down. The next one is this story I have already explained you. You see, the root switch is A. The root switch is A, but the one who is sitting in the switch D, the engineer who is sitting in switch D, or he may be an attacker also, he wants to confuse your network. So what he is trying to do is he's trying to send a superior BPDU which will make switch B to block between A and B, to block. So that's what attacker wants to gain. He do not want the block to be between C and B for some reason. The person who is sitting on D, he don't like packet going via A. He don't like packet going via A because there may be something here which is a disturbance for him. Something, maybe some sort of inspection where this guy is considered not to be allowed, something like that on the switch. Maybe .1x authentication, something like that is there. So he want to bypass switch A. What he uses is a spanning tree to trick and confuse the network. For that, what he does is he sends a superior BPDU. What is superior BPDU? The BPDU that will win the election, the BPDU that will make the other switch as a root switch other than A. But only if A switch is a root switch, you can have your company policy, security, let's assume. But attacker here wants that to be cancelled. Is to bypass A. So when D sends a superior BPDU, A will lose its root bridge. So this ports, earlier it was blocking, now it is open. Now all the conversations can go like this. You need not to go through A always, because there's a block here. That's what you want to avoid. How do you prevent this? By enabling root guard. Root guard. We want this switch to be guarded so that it will continue to be root, whatever comes. We want A to always remain a root switch, whatever comes, whatever the superior BPDU received. Even if another switch sends a low priority, we do not want the other switch to become a root switch. We want A to continue as a root switch. For that, what is needed is A should ignore that superior BPDU. So we want A to continue as a root switch always. For that, we enable root guard so that the BPDU that will win the root switch role, will be ignored, and A will still continue as a root switch. So for that, what we need to do is we need to say guard root on this port, guard root. On this port and this port. When you do that, what happens? When a superior BPDU comes, the switch will not accept, will not change the role because of that BPDU. This is the command, simple command, guard root, spanning tree, guard root. Right? If any switch sends a superior BPDU, that port will go to inconsistency state. Is there any question on guard root guard? Safe?
No, sir.
Right. Yeah. Simple. We need to go under the interface of switch A that connects to B and C and configure spanning tree guard root. Verification command show spanning tree interface F5/8. It says that guard root has been configured. Show spanning tree inconsistent port So these are the ports via which the BPD has been received, so it is not inconsistent state. Right. So in the previous chapter, what we have seen is BPD guard, BPD filter, root guard in the lab. Root guard and BPD guard and BPD filter we saw the lab. Root guard is simply a configuration, just configure and leave so that even if any other switch comes with a superior BPD, it cannot win. Now, I think this is the last chapter in this switch security. Let's see. Preventing STP forwarding loops. See, STP's job is to prevent loop. But what if STP fails? It's a software, right? Basically, it's a software running on a hardware. So failure can be caused by hardware as well as software. Hardware also can fail sometime. Software also can fail sometime. Is there any checking mechanism? Is there anything, if STP fails, still you can prevent loop? Yes, we do. Loop guard. Loop guard. Loop guard is a solution. Along with the spanning tree, it is recommended to enable loop guard. So that if in case spanning tree software, spanning tree, which is a software, which is an algorithm, if it malfunction, if it fails, loop guard will maintain the block. So spanning tree is the one which is maintaining the block. As a result, we don't have loop. But if spanning tree fails and if spanning tree fails and loop, if the block is unblocked, blocking port is unblocked, again loop. If spanning tree fails, loop cannot be prevented because the blocking port will become unblocked. To prevent, we enable loop guard. Loop guard, when you enable, it's simply a command we enable on all the trunk ports or the redundant ports, the path between the switches. We enable on all the links between the switches. Spanning tree guard, loop guard. When you enable loop guard, what happens is a special ping messages will be sent. As long as the ping is available, the blocking port which was earlier maintained by spanning tree will be continued. The blocking port which was maintained earlier will continue. Yeah, that's loop guard. You see here, this is hardware failure. The BPD is lost here between B and A because there is a hardware failure. Because the BPD is not coming from A, B has unblocked its port and loop occurs. You can avoid this by enabling a feature called unidirectional link failure detection, UDLD. This one, UDLD. This is the command to enable UDLD globally. UDLD is hardware failure. Because of hardware failure, BPDUs are not received. See, switch is functioning, no doubt, but some malfunction on the port hardware. As a result, the BPD is lost. So if it is a hardware failure, it is UDLD, unidirectional link failure detection, is a solution. If you got software failure, spanning tree failed. In that case, the loop can be prevented by enabling loop guard. Loop guard will send special ping messages and 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 the blocking port will still stay blocking as long as the ping is functioning fine. This is the command: spanning tree, spelling wrong, global default, loop guard enabled. Right? So see, UDLD enable, global level, interface level. Yeah, UDLD is mostly the fiber optics problem. In fiber optics, only this hardware failure you will see. In fiber optics, there will be two fiber, one for receiving and one for sending. If sending fiber is broken, BPD will not come. The other guy cannot send BPD. In such cases, UDLD can prevent the loop. Alright, loop guard, just spanning tree guard loop. It sends the special ping messages and keeps the blocking port as blocking. So this is what I was telling you. STP failure means software failure is prevented by loop guard. This is not software failure, this is hardware failure. See, miswiring. UDLD can prevent the loop. Right? Any question on loop guard and UDLD? No, we have to configure. No. We need to configure them. UDLD and loop guard are not enabled by default. Only spanning tree is enabled by default. Any other question? Right.
This is only for fiber, sir.
UDLD is for fiber. Loop guard is for Ethernet. Software failure. Next. You see, CDP is one of the vulnerable place using which attacker can gain access to our network device. Yes, even though CDP is considered as a very good discovery protocol to discover the connected device, see, instead of LLDP, all Cisco people will use CDP, Cisco Discovery Protocol, using which one switch will be advertising to the other switch about its identities like MAC address, the port, the type of device, and so on. CDP advertises these informations like what type of device I am. I am a switch. I got this MAC address and I'm connected to you using this interface. These are the informations that CDP will share with the neighbor. These are the informations that CDP will share with the neighbor. Yeah, so the CDP can also be used to attack. See, when you give your MAC address, when you give your interface name, when you give your IP address, when you give your subnet mask, you have revealed everything to me. Then I can use it for good as well as bad. So we have to trim the CDP wherever it is inappropriate. CDP is enabled always by default. Please understand. The CDP is enabled by default on all Cisco devices on all ports, which is very dangerous. So we need to disable them wherever you see as vulnerable, especially on the WAN facing interface or on the edge, DMZ edge or any edges. It is good to disable CDP. You can disable CDP in a global level. It can also be disabled under the interface level. Command is not the same, slightly different. Secondly, you can also tell who can telnet. See, we know how to enable telnet. We go under line VTY, we put the authentication method, and we say transport input telnet. Fine. But we are not saying most of the time which subnet can telnet or which host can telnet. If you are from Palo Alto background, you know what I'm trying to say. We by default say these are the subnets that can do a HTTP or HTTPS or telnet. We always say that. If you don't say that, then everyone can do HTTP. Everyone can do HTTPS and telnet in Palo Alto. Same way in Cisco also, anyone can telnet if you don't specify who can telnet. So use a secured enable password. Try to use SSH instead of telnet, and also try to put an access list and say who can telnet. Put an ACL and say who can telnet. Right, like this. Go under line VTY, call the access class. So what do we have? What did you learn in this chapter? There are some best practices that we have learned. What? Put the system password. Put the port as an access port if you are not going to use as a trunk. Put all the unused ports in an unused VLAN. If possible, shut down them. Enable port security. And if anyone is using telnet, make sure the subnet of that anyone, the subnet of the person is the only subnet that should be allowed. Not everyone can telnet. Better use SSH instead of telnet. If you are using enable password, enable secret passwords instead of plain password. Trim CDP. No CDP is the command on the interface. I think the command should be there in the following page. No? I'll show you the command to disable CDP. To disable CDP on the global mode, you see by default CDP is enabled. Show run. I'll show you. show CDP neighbor. You see, I can see the neighbor, which means CDP is enabled by default. I can see my neighboring device is switch 1. I can see the interface via which I am connecting to him, and I know what my neighbor is capable of. My neighbor is capable of doing layer 3, layer 2, and also layer 1 link device, and it is running a operating system Linux. On the other side, this is the port. If I say detail, I can even see the MAC address of my neighbor. See, I did not configure any IP address, so I don't see any IP address. I can see the software version of the neighboring device. I even know to which VLAN my neighbor belonged to. Okay, so to trim CDP, the command is, I want to stop CDP. Switch 1. I don't like switch 2 learning about the switch. So I go to switch 1 and I disable globally. No CDP, that's all. That's no CDP run, that's all. No CDP run will stop CDP running. Now go to switch 2 and see. Clear CDP table, and now you see show CDP neighbor. Still it is there. It is gone now, and it will never come because the other guy is not going to give any info. You can check it on the other guy. Okay, show CDP. It says CDP is not enabled here. Whereas on this switch show CDP, you see it is running. Every 60 seconds it sends the information about the switch to the other. If the other guy is not sending for 3 minutes, information will get removed. So it is good to disable wherever it is inappropriate. If you wish to disable on an interface, say for example, I'm going to enable. Wait some time, please. Now I'm going to say CDP run. This is the command. To cancel, we said no CDP run. To enable, we say CDP run. This is global configuration mode command. As a result, if you see now show CDP, it is running here also. And if you go to switch 2, you will be able to see the neighbor. So the neighbor has come. If I go here and say, under the interface Ethernet 00, no CDP, no need run and all, no CDP enable. Enable command, instead of run, enable command. There is nothing called disable. That's why we put no in order to disable. No CDP enable, which disables the CDP on the interface. As a result, when I clear here, see the neighbor is gone out, the neighbor will never come. Per interface, CDP disabling is also possible, and this is the command. Switch 1 runs CDP but not on that interface. It is running, but on interface Ethernet 0/0, it is disabled. CDP is not enabled on this interface. Whereas on the other interface, it is enabled. And also put the warning messages wherever possible on switches and on routers, on firewalls, because there are chances that people accidentally get in. So put the warning banners wherever in the home screen. Syslogs. To keep track of things, you need to have syslog. Some devices will have inbuilt logging mechanism, very nice logging mechanism. And I log in by giving wrong passwords. I'm going to say ADMIN BOB password PAL. This is the right password. I have given right password this time. Alright, now again I'm going to log out and give wrong password. That this right password that I have given and logged in, you can see under the, look at this, authentication, local, successfully done at 6:34 a.m. according to this US time. Now I'm going to log out and I'm going to do some attempt. A wrong login attempt. Now this is one user I created recently. Right attempt. And you're going to see both the attempts. Means logs are maintained locally almost on every device, even on routers, Cisco routers. Now when I go to systems and alarms, you see authentication failed because I was using wrong password. Here it gives the invalid username and password information. And then again I tried, authentication became successful. Right, in few seconds difference, this happened. Logs are maintained. You can also use syslogs to dump the log information on a remote device. All that you need is to run syslog services on the device and syslog server on the remote computer. Put the IP address of the remote computer where you are running syslog server on the switch, syslog client configuration. Right, these are all the good practices. And this whole chapter that we saw is about layer 2 attacks and mitigating them. We started with Mac flooding attack, VLAN hopping attack, DHCP snooping, ARP inspection, source guard, loop guard, BPDU guard, root guard, UDLD, .ONX, AAA, Redis attacks, CDP trimming, etc. This is just a sample. There are a lot of attacks. There are a lot of attacks. Attacks using URL. Attacks using, it will look like a Gmail URL. But because you made one small spelling mistake, instead of Gmail, GEMA, you might have accidentally typed yes because the keyboard is the very next key after A is S. It will open a Gmail kind of page which is not really Gmail. You think it's a Gmail genuine page and you start giving the credentials and you are lost. So attacks theft can also be done through data packets. This is just a sample of how to prevent your switch from the attack. Because we are in switching topic, we are not learning here firewall course. Switch. How can a switch be used to mitigate a lot of layer 2 related attacks? Anything that you want to ask, please ask.